Alright, in this video we're going to be looking at problem number 11 in your STAAR packet. Notice that the question says, what function is best represented by this graph? So, we're looking at a function, and what I would say is, let's look at the graph first and just like highlight some things. First of all, if you look at it, we can go straight to our y-intercept and locate that really quickly. That can go ahead and eliminate some choice possibilities for us. So let's do that. Anything that's real easy to do, like marking origin or marking the y-intercept, we should go straight to that and do that. Now that mark, if you notice, this is 1, 2, and 3. That's at positive 3. So that point is at 0, 3. That's our x and that's our y value. So my y-intercept, I'm just going to write it right here. Y-intercept is equal to positive 3. So I can go in and go to my answer choices and eliminate anything that's not positive 3 on the y-intercept. So let's look down here and see what can we eliminate. Now remember, this is not proportional. It does not go through origin. So the equation we're dealing with is actually going to be y equals mx plus b, which is non-proportional. Just to help you remember from our lessons that we had done earlier. So here's my y's down here, right? That's all good. Here's my slope. We don't know that yet because we haven't counted it. What we do know is our b. We know our y-intercept is equal to 3. So b is equal to 3. So I can eliminate any of these answers that doesn't have a 3. So for instance, f, it has a 6. So f's not a choice. H also has a positive 6. That's not a choice. So now I just have either g or j. So my slope is either negative 2x or negative 1/2 x. So since both of them are negative, we can look at this slope and see that we're running downhill if we go across the graph from left to right. And with that being said, since they're both negative, we just got to see, is it 1/2 or is it 2? So what we can do is we can go ahead and find 2 points, and I'm going to use these 2 points. Here's my x-intercept. It crosses perfectly right at positive 6, and that's where they try to mix you up. See, they're trying to see, were you going to mistakenly say the x-intercept was your b? But we know that's not the case. The b always represents the y-intercept. But we can use that point. We can go up here and then go over. And now we just need to count our rise over run. So our rise is going to be 1, 2, 3. So my rise is 3 over, and my run is 1, 2, 3, 4, 5, 6. And that's over 6. So if we go ahead and simplify that, 3 over 6, that's actually going to give me 1. Alright, so what we can see is we have 3 over 6, and that's equal to 1/2. So if we want to check it in our calculator, we just put it in our calculator like I did. Notice I put 3 over 6, and once I hit enter, it gave me 1 over 2. So now we know that our slope is going to be a negative, and if you're like, well, why did you say negative? Well, remember, we're walking downhill. If I make a little guy, he's going downhill. So since he's walking downhill, then that tells me it is negative. So we have a negative 1/2 slope. So now we can go back to our answer choices and go, okay, we have negative 2 here. Well, that's wrong, so it's not g. And here we have our negative 1/2. So it meets both the criteria. Our y-intercept is 3, and there's our 3 right here. And our slope is negative 1/2, negative 1/2. So J is the correct answer. Alright, in this problem it says the graph models the value of a machine over a 10-year period. Now, notice that on this graph, it doesn't start at origin. Do you see that? It doesn't start here. It actually starts here. So it has a y-intercept of 8. Then it says which equation best represents the relationship between x, the age of the machine in years, and y, the value of the machine in dollars over this 10-year period. Now, before we do anything else, I want you to take a look at our answer choices, because that's what I like to do first. Notice our answer choices are written in the form of y equals m times x plus b. Now that you know this, right, we see this equation, we go, oh yeah, it's non-proportional, and we can look at this graph and agree that it is not proportional because it doesn't go through origin. It starts through a y-intercept of positive 8, which is our value in thousands of dollars. So it wants us to form an equation that represents this idea, what we see in the graph. With that being said, we just need to find our slope and we need to find our y-intercept, and we're good to go. Now, we already marked our y-intercept because that's where our graph started. It's where it crossed the y-axis, and it was 8. But what we have to keep in mind is this is in thousands of dollars. So we need to multiply that 8 times 1,000. So my y-intercept, I'm going to write it down. My y-intercept equals 8,000. Now, with just looking at our y-intercept, with nothing else, we can go ahead and cancel out two answers. We know that it can't be A because look, its y-intercept is 2,500. Well, that's not possible. D says the y-intercept is 2,500 again, so that's not possible. So now we got a 50-50 chance of getting this right. It's either going to be B or C. We just need to know which one of these answers it is. Now, you might not remember I told you that if we want to be completely accurate, we got to count the slope. But with these two answers, we really don't even have to count the slope. Because notice one of them has a negative sign in front, and one of them does not. This is a positive slope, and this is a negative slope. Well, look at our line. Is this line negative or positive? And you should recognize that if we were walking on it from left to right, we would be walking downhill. And whenever we walk downhill from left to right, it is a negative slope. And when it's a negative slope, it has a negative sign in front of the value. Therefore, B would have to be the correct answer because C shows a positive slope. That would mean that we'd be going up, and that's not the case. It's false. So B is the correct answer. Alright, here we have another one. It says, which equation best describes a relationship between x and y in the table below? So now they're giving us a table. Once again, we're going to find two things that are extremely important to us that we've been doing all week long, and that's find the y-intercept and find the slope. So notice that if we look at all of these, they all have a plus 5, plus 5, plus 3, plus 5. They all have some value that's being added to the end of the equation. That should be a hint that this must be y equals mx plus b. So it's slope-intercept form. That means it's non-proportional. And if we look over here, we're going to see that we have an x value of 0. Remember what we had talked about in class, that if you see an x value that's 0, that tells you that that y value must be your y-intercept. Because if we had a graph and we cross through it, our y-intercept is right at this point. And when it's right at that point, our x value for our x-axis is always going to be 0. So the y-intercept is going to be 5. That already helps us out because now that we know our y-intercept is 5, we can go ahead and start eliminating some of these answers. So if you look at it real closely, we have a 3 for B. Well, it's not 3. We see that clearly when x is 0, y is 5. That is our y-intercept. So B is not a possibility. We can also see, let's see, 1, 2, 3. Now the rest of them are 5. So we can't cancel out anymore. So this one may not be as easy as the other ones. So let's take our next step. The next thing we need to do is find the slope. So we need to know, well, which one of these? Is it a slope of 1, a slope of 1/3, or a slope of 3? So for that, we can actually look at our difference in x and our difference in y, or we call our change in y versus our change in x. So our change in y, if we go from 0 to 6, right? We could say, if we wrote this mathematically, we would say 6 minus 0. And 6 minus 0, well, that's just 6. Then here, we'd have 7 minus 5. 7 minus 5. That's going to give me a positive 2. So we changed a positive 2 here, and we changed a positive 6 here. Now, it's key to remember that when we write slope, it's rise over run, which is represented by our y, our change in y, over our change in x. So our change in y was 2, and our change in x was 6. So now I can tell by looking at this that this needs to be simplified. And for those of you who want to use your calculator, nothing wrong with that. You can go ahead and simplify it because sometimes even in simple situations we can make easy mistakes. Putting it in your calculator is a sure way to make sure you get it right every time. 2 over 6 gives me 1 over 3. So that's simplified to 1/3. And that's going to be our slope. That's going to be our m. So our slope is 1/3. So now that even though we have 3 5s, we just need to find the slope that's 1/3. This one says the slope is 3. So we know that's wrong. This one says the slope is 1/3. That is the correct answer. And this one said the slope was 1. That's way off. Alright, now this is problem number 24 in your packet. It says the graphs show the cost of attending a county fair on Thursday and on Saturday and playing X games each day. Based on the graphs, which statement is true? Now, notice this should look familiar to you. We've seen a problem much like this before, and I want to go ahead and go over this and make sure that we can answer this successfully. Now, it's going to give us 4 different scenarios. We need to make sure that we read all 4 and eliminate them before choosing the correct answer. So let's look at the first one. Let's look at A. It says the cost of each game on Thursday is 50 cents less than the cost of each game on Saturday. So let's see if that's a true statement. It's saying that the cost on Thursday is 50 cents less. And this is where it comes in. When we have these word problems, it's worth boxing things. And it's 50 cents less than the cost of each game on Saturday. So let's see if that's true. If the cost of each game on Thursday is 50 cents less than the cost of each game on Saturday, then that should follow true for no matter how many games we play on those days. So let's see. For one game, it looks like it costs a little bit less than 12. So maybe that's $11.80, somewhere around there, $11.75. And so if we go over here for one game, we go right here. That looks like that's about 11 and maybe a quarter. So 11 and a quarter to 11.75. You know, that looks like it might be right. It looks pretty close to being 50 cents. Maybe not exactly, but it's really close. So let's check the next one. If we go for 2 games, we go up. That's definitely right in the center at $13. Okay, if we go for 2 games here, we go up. That's right in the center at $13. So here's an issue. If we actually check for 2 games, it goes right through the middle at $13. And if we check for 2 games on this one, it goes right through the middle at $13. In other words, when you play 2 games, no matter if it's on Thursday or Saturday, the cost is exactly the same. So this statement says the cost of each game on Thursday is 50 cents less than the cost of each game on Saturday. Well, that's not true, because if you play 2 games on Thursday or on Saturday, it costs the exact same amount. So we cross that one out. Say that is not true. Question B. It says a person would spend $4 more to attend the fair and play 6 games on Saturday than on Thursday. So let's see if that's true. It's saying they're going to spend $4 more to attend the fair and play 6 games on Saturday than Thursday. So let's see if that's true. We can go to 6 games real quick. This says number of games. Okay, we're going to go straight over to our 6. And once we get to our 6, we're going to go ahead and see what the cost is. So if we go up to 6 right here, and we come across, that looks like that's at about $19 roughly. Then, let's see, and that was for Thursday. That's for Thursday. Then on Saturday, if we go to 6, and we come up, and we go through and follow, it looks like it hits roughly at $23. So now it's saying that a person would spend $4 more to play the games on Saturday than on Thursday. So let's see if that's true. So we got 23 over here on Saturday, and it costs 19 on Thursday. If we subtract that, 23 minus 19, and feel free to put this in your calculator if you want to, but that gives us 4. So in this case, we see that B is correct. A person would spend $4 more to attend the fair and play 6 games on Saturday than on Thursday. That is a true statement. So it is the correct answer. C, just to make sure we don't have anything else that looks like it could be correct, says the cost of each game on Saturday is $2 less than the cost of each game on Thursday. Well, we've already proven that's wrong, because on Saturday for 6 games, if we take a look at it, it's 23, and then if we go over here, it says on Thursday it's 19. What says the cost of each game on Saturday is $2 less than the cost of each game on Thursday. Well, that means, first of all, Saturday will be cheaper. And just with that being said, we know that this is absolutely a false statement, because if Saturday is more expensive than Thursday in our other scenario, it's impossible that each game is $2 less. So we just cross that out. No way that's true. Now our next one. It says a person would spend $3 more to attend the fair and play 5 games on Thursday than on Saturday. Well, once again, it's telling us the cost is higher on Thursday than on Saturday. And by looking at these numbers here, you can tell that is not the case. The games are actually more expensive on Saturday than on Thursday. So, once again, that's a false statement.